Good morning, all of you. Today we are going to learn the topic motion, uniform motion and non-uniform motion. In the case of uniform motion, the speed of the object remains same, means the motion of object is uniform when it covers equal distance in equal time intervals. For example, a car moving on a straight highway, like a train moving on a railway track. Like we take one example, we take a ball starting from point A. In 1 second, it is moving a distance of 10 meters, and in 2 seconds, it is covering a distance of 20 meters. In 3 seconds, it is covering a distance of 30 meters. Means in every 1 second, it is covering 10 meters. So we can say the speed of the body is 10 meters per second. Now, how we will calculate how we get it. Time and distance from position A, we have made one table. According to this table, we have drawn this graph. We have plotted this graph. And we see that this graph is a straight line inclined to time axis. Now, if I calculate the slope of the slope of the graph is y2 minus y1 upon x2 minus x1. What are y2 and x2, y1 and x1? These are the coordinates of the two points taken on the graph. Let us take 2 points. Any 2 points I can take x1, y1 and x2, y2. When I have the coordinates x1, y1, x2, y2, I can put the values and I can find out the slope of the graph. Now, when I am finding out the slope of the graph, the unit of the answer comes out to be meter per second, which is the unit of the speed. And therefore, we can conclude that slope of the distance time graph gives the value of speed of a moving object. This is very, very important. Distance time graph slope gives the value of speed. And if it is displacement time graph, then we can get the value of velocity. Now we will discuss about non-uniform motion. Non-uniform motion means when the speed is not same, means unequal distance with equal time intervals, or we can say a car moving in a traffic area approaching the station. Now we take this example. Let us assume the car. Let us take the car. In 1 second it is covering 2 meters. In 2 seconds it is covering 6 meters. In 3 seconds it is covering 12 meters. Means in first second it is covering 2 meters. In second it is covering 4 meters. In third second it is covering 6 meters. Means the speed is not same. So we have made this table from the given data, from the given values, and from this table we draw the graph. We plot the graph, which comes out to be a curve, which shows it is a non-uniform motion. Means when the body is not covering equal distance in equal time intervals, the speed is the motion is non-uniform motion. And the other name of non-uniform motion is accelerated motion. What is accelerated motion? When the velocity of a body is changing with time. Velocity means speed and direction. Means either speed or direction or both of a moving object are changing with time. Motion is called accelerated motion. For example, any object falling towards the ground or moving upwards against the force of gravity, or we can take the approaching train to the station, starting from the station, or the train is starting from a station, the blades of fan are changing their direction at every instant. In all these cases, we see motion is accelerated motion. When you are moving in a car, if you are pressing your accelerator, you are applying the brakes. In the case of brakes also, the speed is reducing. When the speed is reducing, we say it is retardation. We will discuss it in the next one. Now, what is uniform acceleration? Uniform acceleration means that the velocity of a moving object is changing by equal amounts in equal time intervals. Like we have this table. In every 1 second, the velocity is changing by 10 meters per second. In first second, it is 0 to 10. Second, 1 to 2, it goes 10 to 20. Second to third, it goes 20 to 30. Means in every 1 second, the velocity is changing by 10 meters per second. And the graph I draw here on the y-axis, it will be velocity. And the graph we get, it comes out to be a straight line. And the slope of the graph here, again, it is y2 minus y1 upon x2 minus x1. Now, when I put the values of x1 coordinate and y1 coordinates, what we get? On this axis, the y-axis, if I say velocity at it is meter per second, we have seen in table it is meter per second. So when I calculate the slope, I get y2 minus y1 in the units meter per second and x2 minus x1 in the unit of second. So the unit of the result of the slope we get is meter per second square, which is called acceleration. So this is the unit of acceleration. So what we get, the slope of the velocity time graph gives the value of acceleration. It may be calculated retardation if the speed is decreasing. Now your question is identify the type of motion in given graph. Now in the first graph we can say the time is increasing but the position of the object is fixed. So we can say it is the at rest. In the second case, distance time graph is a straight line sloping with the respect to time axis. So this is uniform motion. In the third case, it is non-uniform motion as we have drawn the graph already. Now these are the six graphs. You have to identify what type of motion is represented by these velocity time graphs. In the first case, we say the time is increasing but the velocity of the object is remaining same. Uniform velocity. Second case, when the velocity and time graph is a straight line sloping with respect to time axis, we can say this is uniform acceleration graph because the velocity is changing uniformly with time. From the shape of the graph, we can identify it is uniform acceleration. In the third case, in C part, it is uniform retardation because the velocity is decreasing with time. In fourth case, it is again uniform acceleration, but its initial velocity is not zero. Here, initial velocity is not zero, means that time t is equal to zero, there is some value of velocity. In this case, E part, it is non-uniform acceleration because again, the curve. And in this last part, it is at the velocity is zero at some time we have started the operation. Okay, when we started the observation, the time is not zero, but velocity is zero. So from here A to B it is uniform acceleration, B to C it is zero acceleration because velocity is constant, and C to D it is uniform retardation. So these are the interpretation of the graph we have drawn. Thank you.